Research is formalized curiosity, it is poking and prying with a purpose. So said Zora Neale Hurston. Number systems are a thrilling subject of research, perhaps the simplest and most significant one at the same time. Poking and prying numbers for specific ends or just for the love of play. But what are the ground rules for cooking number systems and how to ensure it serves any purpose? What does it take to create a working system of numbers? What is a number system? What do we imply by calling a set of numbers a system of numbers? We can explore this in a few ways, but the best is learning to make number systems. And how do we make our own number system? One way is to start with the ideal, desired set of numbers and find the common mathematical thread that uniquely connects all the numbers. That common thread is the definition of a number system. The obvious other is to state the ideal, common feature, to be displayed by all the numbers and then list the numbers as and when needed. We will investigate the decimal number system to decode what gives integrity to numbers. Our high familiarity with decimal numbers makes it easier to make sense of how the numbers decompose and recompose. The first observation is that every number in a number system can be recomposed by adding a characteristic number to its predecessor number. The same characteristic number could be used to decompose the number to its predecessor number by subtracting it from the number. Every number system has a definite number that is the difference between any two numbers in the system. There is the same common difference across a number system. The second observation is that every number system has to start with its anchoring digit, the first digit over which the common difference starts to work on. Adding the common difference to the first digit creates the second digit of the number system. The third observation is that there are only a set of number symbols that are used to create all the other numbers. These are called the digits. Decimal has 10 digits, and that is why it is named so. The fourth observation is that a minimum of 2 digits are needed to have a working number system, the first and the second digit. Such 2 digits give away the first digit and the common difference. If there is only one unique symbol, or one digit, it can be either first digit or common difference. If one symbol is the first digit, then no more digit possible. If it is common difference, then no starting digit. Interestingly, we are now ready to define what is a number system or what is a workable number system. It is a system of symbols used to quantify things such that there shall only be one way to symbolize a given quantity of things in a given set of symbols. An efficient number system has a small set of digits to write all the possible valid numbers in that system. However, the fixed or the common difference of a number system could be any quantity. That is, the difference between two consecutive numbers of a number system could be anything. But then it will stay as the difference between any two consecutive numbers. And numbers that are apart by another number will have the difference of twice the common difference. The chosen common difference of a number system is for a reason. Most importantly, the common difference is the unit of counting or measurement of the number system. That is, every number in a given number system is a multiple of the common difference plus the starting digit. For example, when measuring the distance between celestial objects in the deep space, we use light years as the unit of distance. We express distance in terms of multiples of light year. A light year is about 9 trillion kilometers. The two things needed to make a system of symbols that precisely and uniquely quantify to be counted things are the first 2 digits, or the starting digit, and the common difference. Here are a couple of interesting number systems. First, a number system whose starting digit is not a zero or no quantity. Natural numbers start from 1. It goes without saying that the starting digit could be anything. It all depends. The second example is really interesting and effectively concludes the discussion on making number systems. It is the unary number system, which has just one digit. This digit can be used as the starting digit or the common difference. In either case, it could be used to count things by using the symbol repeatedly, as it is the only way to form other numbers. It is important to note that such a system would not be a positional number system. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.